Hi, and welcome to our part 6 of our series of videos that looks at jigs and fixtures, basic jigs and fixtures for the home shop. So we were just getting ready for drilling, and well, let's get back to the mill and start looking at that. So we wanted to find the two reference surfaces here, their edges, so that we can determine where the reference point is, the intersection of the two. Zero myself there so that I can move 370 in X, 370 in Y, and position myself right over the first hole that I have to produce. That's what I want to do. And for that, well, I'd probably use an edge finder. I'm going to use an edge finder. It's a very easy to use and simple tool that's used to find edges. Thus the name, edge finder. Not everyone has one of these, and there may not be a real reason to buy one if it's not something that you use very often. So I'm going to also show how to, that's the one we're going to use, but before we do that, I'll show how to use something that's maybe a little more accessible, and that is a large dowel pin. It's a ground steel dowel pin. Some drill rod would do the same. It has to be very round, so something that is ground and that's rigid. And with this, we'll be able to edge find our part as well, as long as I use a dial indicator and, you can see here, some shim stock. So let's take a look at how we can do that. But before, we have to determine what the limit of this machine is. There are many limitations here. And you're going to probably wonder, why don't you use your most accurate method to position the two holes, because, well, you want it to be as accurate as possible, and I do. I'm going to be very careful here, but I'm realistic as well. I don't have any illusions about this machine. This is a great home mill. I've been using it for years and years, and it has always served me well. But you got to admit, if I had a good Deckel, Maho, or another high-quality mill, the spindle bearings on those mills would cost more than this whole mill cost me. And what does that say? Well, that says that I accept that it's not going to be perfect, far from it. There is some play, a couple of 10,000ths probably of play in the bearings, and, or maybe just one, but there is some. And this drill chuck here is probably older than I am, and there's going to be something out of whack in there also. So you can't go crazy here. If I do manage to get my holes within 1/1000th of an inch, I will be very happy. So we'll measure once we do get the holes, and we'll see if we got lucky or not. But for now, let's find some edges. And I'm talking about limitations because we'll insert this dowel pin into the drill chuck here, tighten it down without killing it, and we have to find how out is this dowel pin. It's not a bad exercise, because if you learn to do this, well, you'll learn how to position rods in large installations and find their proper position, even if they're not quite straight or they're a little out of position as far as concentricity goes. And for that, well, we have to find the midpoint in this pin, because it's the midpoint that I'm going to use in order to edge find my two surfaces. So let's do that. Come in closer, we'll see how it goes. Now, I don't know how out of round my spindle is, the spindle bore, this drill chuck, how much looseness I have in my bearings. And well, I got to accept that that's going to exist. So I'm going to use this technique to find the midpoint so that I can, even if there is some out of roundness here, accurately edge find using this dowel pin. So I'm going to come up here to a 0 point. Let me just start this out by eye. I'm going to turn. Without pulling or pushing on this, I'm going to turn to find the high spot here we have plus 0.02 of an inch, and the low spot. Turn, come back. Almost 1 thou, but not quite. So 2 thou, almost 1 thou. I'm going to have to move this to position myself a little more under 0. That's the wrong way. Come on. Just something like that. Okay. Now we'll check again. Turn. Slowly, without pushing or pulling. Find the high spot. Come back. There. Okay. So I'm almost 1 thou and a half here. I'd say 1 thou and 2/3. And now we'll find the low spot. And I am 1 thou and a half and a little more. So I'm going to have to adjust that again and come back just a touch. Okay, so 1 thou and a half, 1 thou and a half. So that's the high and the low spot. I'm going to come back very delicately to 0. Because that 0 right there is the midpoint between the high and the low. And at that very spot, this pin is straight. And at that very spot, this pin measures exactly its diameter. At the high spot, as it turns, it's bigger, and at the low spot, as it turns, it's bigger. So I'm going to make a mark right there. Don't have to be deadly accurate here. Just make a mark about at the front there. Okay, so I'm a little this way. We'll have to work that out. Now, I'm going to come here. I'm going to put myself down at the bottom here. I'm going to reposition myself so I'm close to the center here with my contact point, and I'm going to check again. So I'm 3 under and 2 over. Now, this pin isn't only out around, but it's turning a little out of axis as well. It isn't the end of the world. We're talking about 1/1000 of an inch here about. So here's -3, here's +2. So if I move here to 2.5 by moving the y-axis, oh, no, that's just a little too much. Not a little too much. I'm going to get there. I'm going to get there. There, 1.5 thou. It moved a little bit further. Come on back there. Come on back there. There, okay. So 1.5 thou. Oh, 2.5 thou, sorry. Then I'll come back and I have 2, almost, well, a little over 3. So I have to come back a ways there. There we go. 2.5 plus a little bit, 2.5 plus a little bit, and my midpoint will be right there. Oh, I went past that a little bit, right there. So we see here that my spot isn't exactly in front, but it's close, really, more than close enough. So I'm just going to erase this spot here, a little bit anyways. I'm going to put another one right there. It's almost in the same place, but this will be a little better because I'm going to be using this end to do that. What does that mean? When I come and use this pin to come and lean up against the surface, well, I'm going to have to use that exact spot as a contact there. And that will be the proper diameter for this pin, even if it is a little out around. Now, you say, why are you tuning it that way? The surfaces are in there. Well, I'm going to have to do something bizarre here. So let's take a closer look at the part now. I have a problem here. Well, I have a lot of problems, but I have a problem with my part. And that is that on this mill, I don't have a digital readout. And if I want to edge find and move to a point accurately, I'm going to have to make it so that I can always move in the right direction. So to do that is pretty well impossible here. There's ways around it, but I have to touch off the inside edge, and to get to the hole, I have to move in the other direction. So I'm always going to be contending with backlash, and it is going to be a problem. But I can do something to work around that problem very easily, and that is to project my reference surfaces upwards or outwards, depending if you're on a lathe or on a mill. So what I've done here is, this is my reference surface now, because a reference surface has two sides, but no thickness. It's a bizarre kind of surface, but that's the reference surface and that's the reference surface. So if I touch off this surface, it's just like touching off the other. But let's look. If I come up and touch this surface, and then I come up, I advance half the diameter of my pin, that puts the center of rotation right over the surface that I want to edge find. I've found it. Then I can move from that 0, 370, and that positions myself in X. Then lock the X in place, come up to this surface, touch that one off, keep moving in the same direction, half the diameter and 370 thousandths of an inch. Bang, I'm right over the hole that I want to do. As long as I touch off with this side of the pin, I'll be very accurate. So let's take a look at that. This is the side I want to use. I'll turn it there. I'm going to come past my part, and I'm going to work my way down so that I can get a contact on that surface. There. So that is low enough to get a good contact here. Now, I want to check, yeah, my spot is there. I want it right parallel with the direction that I want to move. So I want it right there, right in there. So now you're going to ask, how do I know how hard I'm touching it? Am I touching it lightly? Am I touching it strongly? How do I know? But remember, if it's red, swollen, and irritated, don't touch it at all. Go see your doctor. But in this case, well, that's what the shim stock is for. Shim stock is often used to give us a feeling for what's going on. Now look at this. I'm going to have to do this a little awkwardly because I don't want to hide the view. But if I come up here and just slowly come close to where I'm going without leaning up on it, and look at, I can move my shim stock. And I'm going to move in slowly so that I just feel a resistance. I don't want to pin the shim stock there. I just want to there. See, I can just move it, but it's holding on there. So it's just snug in there. By the way, this is a 4th ounce shim stock. You could do it with anywhere between a 3 and a 10. I prefer a 4 because it's just that rigid. Now, you have to judge the situation here. I can move that and I can feel how it's moving. So that means that it's 4 thousandths of an inch, it's just snug, 4 thousandths of an inch from touching that surface. So I can now bring that out of there, set myself to 0, get this out of the way, and move 4 thousandths of an inch, never backing up. So there. You can't see that, but I've actually gone forward 4 thousandths of an inch, and this edge is bang over that edge there. Now, this pin is 3/8, so half of it is 3/16, and that's 1/875. So let's move ahead by 3/16. So that's 108 major divisions, and 75 is 7.5 lines. There you go, 0.1875. So that puts the center of this pin bang over this surface. I'm going to put my scale to 0 here, and I'm going to move the 370 that I have to move to get to the point where my hole is. So that's 1, 2, 370. 70. There I am. That's where I want my first hole in the x-axis. And I can do the same thing over again in the y-axis. We won't look at it, it's the same thing. I just have to turn my pin 90 degrees so that when I touch the part here, I'm touching with the good surface. So let's get this out of the way, set the edge finder up and take a look at that method. So my edge finder is mounted in the spindle, and remember we have a video that looks at edge finding from A to Z, and well, you can always go and take a look at that for details that I might not get into today. So my edge finder is in the chuck. And what's nice with edge finder also, it's easy to use, it's simple, it's reasonably accurate, and well, it doesn't matter how out of round anything is, it's going to give you the center of rotation. So I can position myself height-wise, come up close without touching anything, so I'll just go right there. And I want this to be eccentric at the start, and as I approach my surface, it'll become more and more concentric, and since this is a floating tip, as soon as it hits the spot where the edge of this tool is even with the edge of the part, it's going to go and offset itself. So let's take a look at that. Oh, obviously the machine has to be running, so it is going to make a little noise here. Now I'm going to move up to clear the part. I'm going to move over by half the diameter of the contact point tip here, which is 200 thou, so 100 thou, plus whatever I have to move. What's nice here is 100 thousandths of an inch is a fun dimension to add on to something else. I want to move 370, so I'm going to set my graduated scale at collar at 0, and I'm going to move 470. So half the diameter of this plus what I want to move. So I'm going to set myself to 0, there we go, and I'm going to move 470. So there's 1, 2, 3, and 470. 470. That's where I want that hole to be in the X dimension. I can lock that in place. I don't want to move that anymore. Now I'm going to come and do the same thing in the other axis. So I'm going to come down. I'm going to snug that there. I'm going to start up the machine and come in contact with the surface. Right there's what I want to be. So I'm going to come up again, move 470. So I'm going to set myself to 0, and I'm going to want to advance 470 thousandths of an inch, half the edge finder's diameter, the tip, and well 370 for the hole position. So 4 full turns, and again 7 main divisions. So 1, 2, 3, and 4 plus 7 main divisions, 0.470. We're good to go. Okay, we're in position over our first hole, and we're ready to start machining. We want to center drill, drill, and ream. Now, we have a problem here, is that I can't move the head on this machine. It's a round column mill. While I'm machining, because, well, obviously I'm going to lose my position. This head can move around the column when I raise or and lower it, so it's not accurate. There's ways around that. First is to use the longest tool method, and that's what I'm doing here. So I have 5 inches of movement on my spindle. So all I have to do is make sure that the smallest or the shortest and the longest tool don't have more than 5 inches difference between them. And that means that if I set up for the longest tool, well, I'll be good to use the shortest one without moving the height of my head. Now, if I had to move the height of the head, well, there's tricks around that too. There's a touch off method for keeping alignment, and there's even a laser method right here, and a line on the other end of the shop, about 20 feet away, a line on the wall. And that seems odd, but it can keep things quite well aligned. Don't worry. Longest tool method, touch off, laser, whatnot. We look at all this in a specific video. I have a series on round column mills and how to work around the problems that they have and how to use them properly. So you can go check that out. And I have another video about round column mill modifications that can really help out. So take a look at those if you want to. Now, the last thing before we start to machine, I may want to move this table in X. Sometimes to have 5 inches difference between the longest and the shortest is fine. That doesn't mean you're going to be able to get the longest tool out of there because of its diameter and its length. It might not clear the part when you want to pull it out. So what am I going to do? I'm going to move my X. How am I going to find out where I'm going to be? Well, I've set my X at 0, so I know that. But which 0? Because if I back off a few inches, I don't want to have to count 20 turns to come back. I may make a mistake. And that's what this chalk is for. And we see that in the round column mill tips and tricks videos as well. And I'm going to use this to just make a line between the table and the cross line, because that will be my reference, light reference. If I move this in X, I don't have to move it in Y ever. But if I move it in X, well, I'll back up to clear so I can remove a tool, set the next one in, and then I want to come back. I don't have to count my turns, I just have to come back. And when I see that the 2 marks are going to almost align, I stop, I look, and I move to the next 0. And I'll be exactly where I was the last time, without a big headache of counting, and risking making a mistake. So I'll make my line, and now we're ready to start machining. From there, I'm going to want to advance 1/2 inch for the position of my second hold. It's on the same Y, I just have to move X here. Once I'm there, well, I'll reset my 0, make a new chalk line in case I have to come back to it, and then I'll center drill and ream again. Now, some of you maybe have caught on to the problem here. The problem that we're up against is that I have 2 1/2 inch holes spaced by a 1/2 inch. That's problematic because when I drill, the second reamer is going to want to wander towards the first hole. Now, to reduce that possibility, I've chosen a right-hand spiral flute reamer. Now, the spiral isn't pronounced, but it's there, and that'll help with that migration problem. But there's another way that I can ensure that we don't have a problem. Now, these holes aren't going to break into one another or they barely are. We're talking about a thousandth of an inch here, so or no thousandths of an inch. We'll see where things go, but the problem can be resolved to make sure that you can't get into trouble with this. All this is a little brass plug. It's a 1/2 inch. In its largest end here, it is a couple of tenths over 1/2 inch. And then it slightly tapers down to maybe 2 or 3 thou under a 1/2 inch. And that makes this very easy to press into that hole. And seeing as it's just 1/2 inch, it's going to support the reamer and support the wall of the second hole so that it doesn't break into the first hole. So we'll press this in place. Now, some people are saying, oh, you're going to have to remove that part to press this. This is a light press fit. And well, I have something that resembles a press anyways. Now, I don't want to use the spindle here to press very, very hard. But as I said, this is a very light press fit. So I'm going to just use the spindle. I'm going to move above the first hole about. I'm going to press down or just position it with that and press it. And then I'll come back to 0 because I've made my second chalk line. I've set myself to 0. I can come back to that second hole in X easily anytime I want. There you go. I'm pooped again. So that would be enough for today. Next time we meet, well, we'll be producing those drill guide bushings and, well, moving on to checking to see what results we've got as far as positioning goes. And then, well, we can try the jig. So, until we meet again, have fun, be safe, and happy machining.